What's up, guys? Alright, today we're going to do a little bit of automation, the car company tycoon game. I'm going to do a sandbox mode. We're going to just be building an engine today. Just kind of gonna go with it, I guess. Not really sure what exactly we're going to do. I do know it's going to be a V8, but besides that, just kind of leave it open. Try to get the most horsepower, naturally aspiration, and as far as uh, CCs or whatnot. Not really going to worry about that. Just going to make a big naturally aspirated engine. So here we go. Going to do a V8, aluminum block. Let's see here. 496. Let's see, is this still a small block? It's a wide bore at that, but again, still a small block. Alright, we're going to do, let's see. Can't decide if I want to do push rods or an overhead cam. If we go overhead, we're definitely going dual. Let's start out with push rod and see what we can get out of lifters with a cam. Aluminum heads. Alright. Billet crank. And of course... Yep, nice billet crank. We could do cast iron, but I think that the billet still is going to be better in the end. I'm going to go with forged, lightweight rods, pistons, lightweight forged. Again, we're trying to get the most out of this engine. I'm going to start around 11.6 on our compression until we dyno it. Of course, we will play with that. We will play with timing. It's going to be naturally aspirated. I'm going to start out with a 4-barrel carburetor, single configuration. We may end up going to injection. I just want to kind of get a baseline on it here. Again, we'll play with timing and stuff like that here in a minute. Turn around 8,500 to start out with. Should be good on a push rod engine. Let's get us some good headers on it. Of course, it's going to be bypassed. Alright, so we're experiencing valve float, which is sort of expected out of a push rod engine. Let's just go ahead and dyno it here and see what we're dealing with. Alright. Obviously it broke. Let's try one more time. Alright. Let's go back and play with it a little bit now. I'm going to say about a 3.5 on the... maybe a little smaller. Alright, let's see our cam. Compression wise, back the compression up so we can get out of our fuel here. 520, and then you don't want to have an extreme amount of valve float. That's all we're going to get out of that one. Titanium's a little bit more heavy duty. So essentially this is going to be like what would be considered a super engine, or for late model wise. Of course, you do see I do a couple videos on some racing stuff, so this would be like a super late model engine the way it's configured right now. For the most part, there may be a couple things that are off, but as close as we can get it as far as the game. I do know the horsepower's off. They're getting a lot more horsepower out of them, but they're not injected. So that's what we're getting right now out of a naturally aspirated engine. And again, I don't think there's anything drastic we can do. We'll run it one more time here. Of course, once we start messing with injection, we're going to get a lot more horsepower out of it. But again, this is a 496, or you could just say a 497 as cubic inches, of course. I don't think we're going to get anything else out of it. But we'll try here and see what we can get. Saying about 530. As you can see, the airflow is restricted. So once we go to injection, that's going to be a lot better as far as the airflow. So we're going to run it one more time here. And of course, that time it did not break. Got everything fixed. We were turning at 8,300, so 8,300 RPMs or 8,300 revolutions per minute. Alright. So that's what we're dealing with right now. Gonna just run one more manual test on it, and then we're gonna open this bad boy up. That popping tells me that we're not getting enough air to it, so it's running a little bit off. Alright, so let's go ahead and open this thing up. We're going to get our cam all the way up. Still naturally aspirated. Let's go injection. We're going to go all out on our injection here. So this would be kind of like a LS engine, except for, as you can see, we're all out. One thing that doesn't make sense in this game is, if you can kind of see this right here, we're directly over the heads with this, of course, you know, the direct injection. But usually your lifters are right in here, so I'm not sure why they don't have some type of illustration for that. There should be lifters there, but there's not, so that's what you get, I guess. Of course, there's the lifters, but all I'm saying is it's not, you can't really see it like you would on a real engine. Kind of resembling a 350 small block here, so that, and I don't know where the distributor went, so that's not convenient. Alright, let's see what we can get out of this. I don't want to show the horsepower yet until we get in here. The fuel mixture is probably going to be off if I had to guess. So we'll see what that does. So it's running pretty promising thus far. It hasn't blown up. We probably can go up on RPMs once we get some other things sorted out here. Let's go ahead and run our test. .742 horsepower. A little bit of valve float at the top end, but that's not too terrible. That's just going to come. As far as with the engine setup we've got, I'm going to go to a 3.5-inch exhaust, and let's play with our fuel mixture here. So we're going to be something drastic we can do. Nothing too drastic. Going to get about 751 horsepower out of it. It's a little disappointing, but let's see if we can back our cam. Oh, yep, back the cam up a little bit. We can get a little bit more. 764. Let's play with timing. See if we can get anything out of the timing. Nope. RPMs are about where they need to be. So the top horsepower is at 7,200, and that's 764 foot-pounds of torque. I'm sorry, 764 horsepower. And then torque-wise, we're at 6,700 with 569 foot-pounds of torque. So looking at that, let's go all out on this thing. Let's put some horsepower to it. I'm not sure what the difference between the flat plane versus the regular. I know they sound different. Let's just try that first, see what it sounds like. Sounds like a 12 or 6 cylinder. Alright, so we're going to go back with the regular billet crank. Gonna play a little bit here with the compression. I know we can go up on compression here. Let's get it in the optimal range there. 796. Let's check our cam here. Anything else? Nothing outside of the cam. Alright, let's go. Let's put dual overhead cams on it. I said I wanted some horsepower, so here we go. We're going to get some horsepower out of it. See, it's pretty cool though, because you can dial the cam on back, and of course you're going to get less horsepower. Alright, that's about all we're getting out of that. Fuel mixture. Not too bad to be naturally aspired. 1120. $11.72. I don't think we're going to get anything out of this engine. Just being honest here. Of course, we can dial back the ignition timing. I don't know what good it does, because looking at this engine, there's not a distributor in it anymore, so that doesn't really make sense. I'm not sure how the overhead cams work. I'm not sure if it needs a distributor or not. Not really sure on that. If somebody wants to leave a comment. But so we got dual overhead cams now. Let's go ahead and bore this thing on out. 662 cubic inches. Holy snickies. So the pistons are gone at that rate. Alright, so obviously this is not very realistic at this rate. That's pretty bad as far as the reliability and all the piston stress, because after, you know, continuous usage, it's probably gonna become shrapnel. But we're gonna go there. I don't think there's any difference there. Low friction, lightweight. Alright, so it's not wanting to turn up. I don't think we're gonna get 1400 out of it. I don't think. At least naturally aspired. And the thing about Bolt and Turbo Zone is when you start Bolt and Turbo Zone, you have turbo lag. So later on, whenever we demonstrate this vehicle in BeamNG Drive, or this engine, once we find a vehicle and build the vehicle in another video, it's gonna really kill the takeoff, and you'll notice that once we do that. So let's run this thing one last time, and we will be done as far as the engine part goes in building our car. And again, we'll get to test that in BeamNG Drive, thanks to the developers of Automation and BeamNG Drive collaborating. We'll get to test this. So we're currently sitting at 645 cubic inches on a dual overhead cam 5-valve V8. Now they do have, this is the 90-degree version, that's how the heads sit, and they also have the 60-degree version. It sits like that. So that's pretty crazy. I don't think you get much, no difference in the horsepower. Let's just try changing a couple things, see if we can get anything else out of it. I do want a naturally aspired engine. I know people are probably going crazy wanting turbos, but just not at that point. It's really hard to keep the turbo lag. And I mean, if we could add nitrous to this vehicle, then I would consider it. But given they haven't implemented that quite yet, you can't do your shots of nitrous, then there's just no point in trying that on our vehicle that we're going to build. So this is going to save some room by going with the 60-degree version. So I guess this would be, what they call like an 8-degree engine, possibly. I'm not sure. Somebody wants to inform me on that. It says 60-degree here and it says 90-degree there. So I'm not sure. I know the difference is the way that the pistons line up according to the crank. I don't know which is more efficient, but anyway, here's what we got right now. So we're going to dyno her and be done. Alright, there it is. So we ended up with 1,382 horsepower, 8,600 RPMs, and 951 foot-pounds of torque. So we went from a push rod to a dual overhead cam, and man, that add a tremendous amount of horsepower. It's crazy. I mean, so technically, you could take and dial this, retard the timing, and then dial the max RPMs back on it, and I mean, with the reliability of it, you know, if you're not turning but, you know, like we'll say like a LS style engine, a maximum of 6,000 RPMs, well, you're sitting at 889 horsepower whenever you know, are chipping it out. I guess you'd use an MSD ignition system, and I mean, you're chipping it out at 6,000, and your torque is 778 at 6,000. So the equilibrium on this engine is right around 5,200. So that's like where the torque and the power are both at the best. So you could run it there, but I would say around 6,000, maybe even 6,500 would be a good area to be on this motor, because if you look at these numbers over here, you're a good ways away from having any issues at 6,500. So that just kind of tells you the reliability on the pistons, what they're rated at. So they're rated at 7,100 RPMs, which of course you can kind of juke it to it, but it's best to just stay under that. So we're gonna go 6,500. This is gonna be for like a regular street car. And of course, when we decide to do our big time race car, we'll kind of dial these numbers up a little bit. We lost some horsepower, yep, in the timing. That's what I thought it was. But like I say, you can retard the timing or even leave the timing alone and go to about 6,500, and well, dang, that's a lot. 1,100 horsepower at 6,500. It's crazy. Wow, didn't even expect that, but we'll get this thing saved, and yeah, we'll let's see. Have a good collaboration here. I'm gonna call this our drag car. But appreciate everybody watching. If you like this video and you want to see more, drop a comment or leave a like, and I'll put out some more content like this. Stay tuned, because when we get back, I'll be running this car in BeamNG Drive. So we'll build the car, finish it up, and either in the next episode or the episode after that, we'll test it in BeamNG Drive. So definitely something to follow. Again, if you like it, just let me know, and I don't mind doing some more. I'm gonna try some other games here too, so whatever floats your boat, I guess. If you want to see some different games, let me know. I'll don't mind trying some new games. So yeah, see you guys later.